Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Sicario by Nicholas Duhale. And here are the rules. Normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, in this case a box. And within a cage, digits must not repeat and they sum to the small number in the top left corner. So, for example, these 5 digits must sum to 22, these 5 digits must sum to 19, these 7 digits must sum to 33, etc., etc. But you cannot have repeats anywhere in the cage. So, for example, something like 37192 works for this 22 cage because all the numbers add up to 22. 3 plus 7 and 1 and 9 add up to 10 each, and 2 is 2, obviously. But what you could not have, for example, would be, let's see, 37381. Because even though it does add up to 22, 1, 3, and 7 add up to 10, 3, 8, and 1 add up to 12, so that adds up to 22 total. We have a repeat in this cage, and that's not allowed. So this does not work here, and this is just typical killer cage Sudoku. And that's part of it. That's actually the main reason why I chose this, because I love. It's always nice to go back to your roots, and I used to do a ton of killer cage Sudoku. Some which were, I think, created by bots. Some that were created by humans, but a lot of them were probably created by bots. So I got really good at calculating things with Killer Cage Sudoku. So we're just doing a throwback essentially. Anyways, if you want to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, so in Killer Cage Sudoku, most important ones are probably adding up cages and seeing what they add up to, right? Because then you can know certain things about certain cells that way. So this adds up to 14, this adds up to 18, and this extended one adds up to 22. 14 plus 18 is 32, plus 22 is 54. So these two digits add up to 9. So it's going to be 1 through 8 here. What about this side? 16 plus 14 is 30, plus 21 is... So 30 plus 21 is 51. 51 minus 45, which is what this entire row would add up to, is 6. So this must be 1, 5, and 2, 4 here. In addition, this cell sees all the remaining digits here. Right, so it sees all of these digits and it sees all of these digits. So obviously, whatever this digit is cannot be in either this cage or this cage. I'm not sure if that helps us much. Same with this, though. These two digits cannot be in the same cage as this. It can't be here, so they have to be... Each of them has to be here. I'm not sure what that tells us. Okay, well, anyways. Let's continue. What else do we have? 18 plus 14 is 32, so the rest add up to 13. 14 plus 17 is 31, so the rest add up to 14 here. 15 plus 14 is 29, so the rest add up to 16. 16 plus 13 is 29, so the rest add up to 16 also here. What about this entire cage setup? Okay, so we have 14 and 15. 13 and 16. So that's 29 times 2, which is 58. 58 plus 21 plus 20 58 plus 21 plus 20, which is 41. 58 plus 41 is 99. That means the remaining 1, 2, 3, 4, 5 cells that are not accounted for in those boxes must add up to 135 minus 99. So they must add up to 36. Is that right? I think so. Oh, actually another interesting one is looking at these, right? Oh, that's actually very interesting. Yeah, let's look at that. The sum of these two cages is 22 plus 19. So that must be 41. But that's 10 digits. That's actually very interesting. So, and I think every combination of these, yeah, it's 41, 41, and 41. Which adds up to a total of 120, 123, because it's 41 times 3. Right? Yeah, so 22 plus 19 is 41. 20 plus 21 is 41. 20 plus 21 is 41. That means all of these cells add up to 123. But we know the central boxes are all see each other, right? So that means this is at most 79. Or sorry, 7, 8, and 9, which is 24. So 123 plus 24. 123 plus 24 is 147. 147 minus 3 rows, or 3 columns, actually, in this case. So 147 minus 3 times 45, which is what these 3 columns or 3 boxes add up to, would be 12. And you have 3 extra cells here, each, in these cells. So this must be 1, 2, and 3 then, right? Because this is at least 6, which means this must be 12 minus 6, and that's at least 6. So this has to be 1, 2, and 3. That must add up with 6, 7, and 8. This is 1, 2, or 3, and this is 1, 2, or 3. This can't be 4 or 5. This is 1 or 2. To add up to 6 here, because we know that's 6. 1, 2, 3, and 1, 2, 3. Therefore, the rest of columns, this then has to be 7, 8, 9. Right. What else do we have here? So the rest of column 3 and 7 cannot contain 1, 2, or 3. Okay. So this is 4 through 9. The rest of column 5 has to contain 1 through 6. Okay. And these are all 4 through 9 here. Right? Okay. This 34 cage has 2 digits, which it does not have. And same with this 33 cage. So this 33 cage doesn't have 2 digits, right? It's 7 in size. So the 2 digits must add up to 12. Well, the problem, okay, well, not the problem. The restriction then means that this digit cannot be in this cage because it sees all 7 of these digits. And it has to be from 1 through 3. Well, the only combination of 2 unique digits with a digit from 1 to 3 that adds up to 12 is 3 and 9. So therefore, this must be 3, which means this cannot contain a 9 here. So this must be the digits, it must contain 1 and 2, and then we have the other digits from 4 through 8. We don't know which one. So one of these is a 9. This can't be 3. So we have a similar thing here, right? This cage has 2 unique digits, not in the cage, and one of them must be 1 or 2. And they must add up to 11, because this is 34. 45 minus 34 is 11. So therefore, this has to be a 2. So this is 2, which means this also cannot have a 9 in this cage. So this must contain 1 and 3 here. Obviously, 1 could be here. This could be 4 through 9. That means in column 3, 9 has to be either here or here. In column 7, 9 has to be here or here. And this can't be 2, so this can't be 7 here. This can't be 2. So this is 2 and this is 3. That means the total of this cage, actually this block without these 2 cells, must be 21 plus 20, which is 41, minus 3 and minus 2, right? So that's 41 minus 5 is 36, and therefore this is 36. This makes this a 9. So this is 9, which means this can't be 9, and this can't be 9 here. So it's 7 or 8 there. This 2 means this can't be 2 here. 2 does have to be one of these 2. We're not sure which. 9 has to be one of these remaining digits here. So does 9 have to be one of these remaining digits here. Interesting. Where does that leave? Oh, that's not true. Never mind. I was thinking something else. Never mind. So one of these digits is 9 here. And they both add up to 14 in the cages. So this is either 914, sorry, 914 or 923 if it's 9. And this is 914 or 923 if it's 9. Well, if that's the case, that means this can never contain 1 or 3 if that's there. This adds up to 16. This adds up to 14. This adds up to 13. And this adds up to 16. If this is 7, that must mean this is 1 and 2, if that's the case, right? If this is 8, it must be 1 and 3. Same with here. So if this is 8, if this is 7, it's 1 and 2, right? Because that would mean the rest of these digits add up to 45 minus 7, which would be 38. So 38 minus 41, or 41 minus 38 is 3, which would force this to be 1 and 2. So if this is 7, this requires this to be 1 and 2. If this is 8, this requires this to be 1 and 3. So either way, I think 8 has to be one of these 2 digits, right? If this is 7, it's 1 and 2. If it's 8, it's 3 and 6. 3, 6, and 1. We do know that one of these must be a 1 then. And then one of these must be a 1. We don't have any other real restrictions there. What about adding this up? We have 41. Right, plus 29 times 2, 58. So it's 99, right? Is that right? Yeah, 99. 135 minus 99 is 36. Ah, this cannot be 9 here because one of these is a 9. This cannot be 9 here because one of these is a 9. So these three are add up to at most 6, 7, and 8. So what are the sums of these cages or these digits, right? At most. We know this adds up to 99. So 99 plus 21 at most adds up to 120. And these two digits must add up to then 135 minus 120, which is 15. And that's the most these can add up to because neither of these can have a 9 in it. So, and this can't have a 9 in it either. So this has to then be 7 and 8, and this must be 6, 7, 8, and 6, 7, 8 here. I don't think we'll have the same restrictiveness here. Right. This is sum is 32 plus 31. Oh, that's interesting. This cannot be 1, 7, and 8. And obviously this cannot contain 1, 7, 8 here. We know 9 is one of these two. But you cannot have 7, 8 here combined. You can't have 7, 8 here combined either. If you have 7, 8 combined here, the problem is that it would eliminate all possibilities for that cell. If you try to have 7 and 8 combined here, that adds up to 15 already. So that's not allowed. So there must be, one of these is a 9, contains a 9, because either that's a 9 or this is a 9, right? Because of where the 9s are in columns 3 and 7. So one of these contains a 9, the other one must contain 1, 7, or 8, and then the other 7 or 8 has to be here. Which means this cannot contain 7 or 8, it must contain a 9 here. So you have 9 with 20. 9 and some 4 other digits add up to 20. Which means that must be 9, 1, 2, 3, and 5. And all of these cells see that cell. So this cannot be 5. So this is 1, 2, 3. Because again, it's 9 with 4 other digits adding up to 20. 20 minus 9 is 11. You have 4 unique digits adding up to 11. That's 1, 2, 3, 5. Guaranteed. So this has to be 1, 2, 3, 5, 9. And again, the reasoning is because one of these sets is a 9. This has to be added up to 15. If we tried to make this 1, 7, and 8, that would eliminate all possibilities for that cell. So this can't be 1, 7, 8. You can only have a 9 or a 7, 8 here. You could only have a 9 or a 7, 8 here. But you can't have 2 out of those 3 in either set. Right? If you try to have 7, 9 here, that already adds up to 16. The only way you could have 2 out of 7, 8 would be 1, 7, 8, but the problem is that would eliminate all possibilities here. And this cannot contain 2 digits from 7, 8, and 9. Therefore, one of the digits from 7, 8, 9 has to be here. one of these has to be a 9, again, because of where the 9s can be in columns 3 and 6, or 7, sorry. So one of these is a 9, which means 9 cannot be here. Where is the 9 in box 8? It has to be here. Since it has to be here, it must add up with 1, 2, 3, and 5 to add up to 20. So this can't be 1, 2, 3, 5 because it sees all those. So this must be then 4, which means this is 4 and 2 adding up to 6. This means 2 cannot be here. This means 2 can't be here, so this is 1, which forces this to be 3 and 6. I don't know why I had 8 there. That's 7. Okay. Is it? Actually, hold up. So this is 2. Again, this is 1, 2, 3, 4, 5, 9. This can't be 2 or 4 here. This is these digits. Again, 41 minus 2 is 39. So this adds up to 39 here. If this were 3, that would subtract 39 from 39. So this would add up to 36, but then this would have to be 9, but that's not a 9 because this is 9. So this can't be 3. This must be 1, which means 1 cannot be any of these digits here. This is 2, 3, 5, 9, which eliminates 2, 3, 5, 9 from the rest of the box. Also, this is 1 and 2 on the outside. 41 minus 3 is 38. 45 minus 38 is 7. So this is 7, and this is 8. Okay, yeah, that is true then. This is 7. This then has to be 1, 6, and 8, which eliminates 1, 6, and 8 in the rest of the row. So this is either... So 2 cannot be here. If this is 9, it has to be 9, 2, and 3 here. So this would be 9, 2, 3 if that's the case. If this is not 9, three digits adding up to 14. No 6 or 8. So if we try to have it without a 7, or it has to have a 7 or 9, essentially. So we have 7, that would be 1, it can't be 1, 6, 7. We need a 2 here, right? Because where is a 2 in row 9? Can't be here. Because of the 2 here, can't be here. This has to have a 2 no matter what. So since this has 2, it's either 2, 3, 9, which is 14, or it's 2 and 7, which means it's 2, 5, 7. So this can't be 4 then. Oh, this adds up to 16. And you have a 1 here, so it has to be 1, 7, 8, adding up to 16. This can't be 6 or 7, therefore this is 8, which forces this to be 7. That means this can't be 7 here. This has to be 2, 3, and 9. So this is a 9. This is 2 and 3 here. We have a 2, 3 pair, which eliminates 9, 2, and 3 from the rest of the row. So this has to be a 4, 5, 7 triplet, which eliminates 4, 5, and 7 from the rest of the box. This can't be 7. This is 8. This can't be 7 or 8, so this is 6. And the rest of this box must be 1, 3, and 9. 1 can't be here. This has to be, what, 4, 5, and 7? No, 4, 5, and 6, adding up to 15. Well, this can't be 4 or 6, so this is a 5, which makes this a 4, 6 pair here. This 7 eliminates 7 in the rest of this cage. And the rest, we can't have a 9 here. Where's the 9 in column 7? It has to be here. So this is this is 9. This cannot contain 3 or 6 here. This can't contain 1. Let's see. 8 cannot be in the rest of this cage. We know there's a 6 in one of these 3 digits, so 6 cannot be here. Nothing else there. This is 4, 5, 7. This 6 eliminates 6 here. And 6 can't be here, so 6 has to be one of these 2 digits, which means 6 can't be here. 6 can't be here, and 6 can't be here, which means one of these 2 digits here is a 6. This could be 1, 8, 9, but can't because of the 1. It could be 2, 7, but the 2 has to be not here. So this is 2 and 7. If it's 6, it's 3 and 6, or it's 4, 5. This can't be 5. 7 has to be one of these 3. 8 has to be one of these 3. So 8 cannot be here, 8 cannot be here, 8 can't be here, so 8 has to be here. Since 8 is here, that means 6 has to be here, which makes this a 3, 6 pair. To add up to 18, this can no longer contain 3 or 6. We have 3 digits adding up to 22 minus 9, which is 13. And you cannot have 8. So this must contain an 8 here. It's either 8, 1, 5, or 8, 2, 4. That means 7 has to be one of these 2. So 7's one of these with 8, 1, 5, or 2, 4. But 1 cannot be here, therefore this must be 1 and 5. So this one being 1, 5, 7. This cannot contain 5 or 1 anymore. It's 2, 4, 8, which eliminates 2 and 4. 2, 4, and 8 from the rest of the box. These 2 digits add up to 14 minus 8, which is 6, so it's 2 and 4 here. That eliminates 2 and 4 in the rest of the box. This is 5, 7 then. This is 5, 7 also. This must contain a 1. So 1 plus 7 and 9 adds up to 17. But this can't be 7 or 9 because the 7 or 9 in box 4 has to be in column 1. So this is a 1, which forces this not to be 1, and that not to be 1. This is a 7, 9 pair. That leaves this as 5 or 6. This can't be 6 because of the 6 in the row. So this is 5, which forces this to be 6. This 5 eliminates 5 here, so it's 7, which means this is 5. So this cannot be 5 here, or here, or here, or actually anywhere in the rest of the cage. That means this has to be a 5, 8, 9 triplet, which eliminates 5, 8, 9 in the rest of the column. This 6 eliminates 6 actually in the rest of this cage. So this becomes a 6, 7, 9 triplet. That eliminates 6, 7, 9 in the rest of the column. 1, so this can't be 6. This is 4, which makes this 6. This is 4, and 8 eliminate 4 and 8 here. So this is 2, which eliminates 2 here. So that's 3 and 2. This can't be 2. That's 3 in the corner. We celebrate because we know we're getting close to solving it. This can't be 3 or 9 because of the 5, 8, and 9 triplet in the column and the 3. So this is a 1, which means this can't be 1. This 5, 8, 9 triplet eliminates 5, 8, 9 in the rest of the column. So this can't be 5. This can't be 4, 7. So this is a 4, which makes this 7, which makes this 5. That eliminates 7 from here. That makes this a 4, 6 pair here, which eliminates 4 from the rest of the box. So this is a 1, 2, 7 triplet. This 4 eliminates 4 here, so this is 2, which makes this a 4. This 7 eliminates 7 here, so this is 9, which makes that 7. The remaining digit in row 2 is a 2, so this is 2, which means this can't be 2. It also cannot be 5 because of the 1, 5, 7 triplet in the box, so this is a 3, 4, 9 triplet? Yeah, 3, 4, 9. And this can't be 4. This 3 eliminates 3 here. This 2 here eliminates 2 here. This 9 can't be here or here. There cannot be a 5 in any of these spaces in column 2. What else are we missing? 3, 9, 3, 9. This can't be 6 because of the 6 here. Okay, Now we're just doing normal Sudoku for the most part. Yeah. 5 is one of these two. Okay, 5 digits adding up to 20 without a 9. And we already have a 2. This must have a 3 then also, because this cannot contain a 3. So 2 and 3, that adds up to 5. 20 minus 5 is 15. So the other 3 digits must add up to 15. Without a 9. Um, hmm. Um, okay. Add up to 15 with 3 unique digits without a 2 or 3 or 9. So you could have 168. Then the next one up would be 4. It has to be 456 then. So 168 or 456. Either way, the 6 has to be cannot be here, so the 6 has to be one of these digits here, which means this can't be 6. Right? Because 168, you can't have any 2 or 3 because we already have those involved. 177 obviously doesn't work. There's no 19, so 159 doesn't work. So 4 as the smallest digit would have to have 456. So either way, 6 is here, which means this can't be 6. This is 4. This is 6. Obviously, 6 cannot be here. We have a 2 here somewhere. So since one of these is 2, this can't be 2 here, which eliminates 2, and which means 2 has to be here. And this can't be 2 because of this 2. This also can't be 2 here. Where's the 2 in column 8? It has to be here. We have a 1717 pair here. This is 6. It's either with 1 or 8. And neither 1 and 8 can be here. Sorry, one of 1 or 8 has to be here, which means the other 1 or 8 has to be one of these two. This 4 eliminates 4 here. Because if we had two 1 and 8s here, that would eliminate all possibilities for 1 and 8 here. So 1 out of 1 or 8 is here. The other one is one of these two if it's 168. Or it could be 456. If it's 4, 5, okay, this can't be 4 anymore because of this 4. So if it's 1 and 8, we have 1 and 8 here. This can't be 3, therefore this would be the 1 or 8. Therefore this would have to be 3. And this would be 6 and 1 and 6 and 1. Or 6 and 8. We're not sure which one. Right, so this would be 1, 8, 1, 8, 6, or this is 4. And we have 4, 3, 5, and 6. We just know one of these digits is a 3, so this can't be a 3 here. Where is the 3 in column 2? It has to be here. So this is 3. Or actually, I guess it would be row 6 is the more important one. This can't be 6 because of the 6 here. Interesting. We have a 1, 8, 5, 8 pair here. And we know one of these digits is either 5 or it's 1 or 8. So that eliminates 1, 5, and 8 in the rest of row 4, which eliminates 5 and 8 here. So this is 9, which means this can't be 9. Whereas then this 9 can't be here then either. Whereas the 9 in column 1, it has to be here. Whereas the 7 in row 4, it has to be here. So this is 7, this is 6. Okay. We know this contains a 7, a 2, and a 3. That means the remaining digits are 1, 8, or 4, 5, right? Well, we know 2 is one of these two digits here. If it's 2, 4, and 5, this becomes a 5, 7 pair here. Right? Because again, we have 2, 3, and 7 in this 21 cage. 21 minus 2, 3, and 7 is 12, so it adds up to 9. So it's either 1, 8 or it's 4, 5 here. And if the 4 is here, the 2 is also here, so this would have to be 5, 7. So this would be 2, 4 with 5, 7. Or, okay, so this could never be 5 here. That's interesting. Or this is some combination of 1, 2, 4, 1, 2, 7, and 8. So 7 could be here. And then we have 1, 8, which could be many places. Okay. Hmm. 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 Okay. 6 is here. 3 is one of these 3 also. And we have 1 of 1, 5, or 8 here. Interesting. Okay, what happens if we have 4, 3, 5, 6 here? Does that lead to contradiction? If this is 4, that means this is 3, 9. This is 3, 9. That leaves this as a 5. So 5 can never be one of these, right? If this is 4, 3, 5, 6, adding up to 20 with the 2, the 4 has to be here, which forces this to be a 3, 9 pair, which eliminates 3 here, so this would have to be a 5, if that's the case. Otherwise, this is 3 with a 1 or 8 here. This 3 would make this a 9, which would make this a 4. So 4 cannot be here at all. Okay, let's go through, I guess, the possibilities. This is kind of painful, but whatever. If this is 4, that makes this a 3-9-3-9 pair, which forces it to be 5. This becomes a 3-6 pair. That means 3-9-3-9 and 5 eliminate 3, 5, and 9 here. So this can't be 2. This can't be 5. This can't be 2 then. This is the 2 if that's the case. Otherwise, this is 1 or 8 or 7. Actually, all of them work. This is 4. This becomes 8, 1. And that's a contradiction. Okay, that's where we wanted to see it. So if this is 4, that means this is a 3-9-3-9 pair, which eliminates 3 and 9 here, which makes this a 5. That makes this 8 and 1. This 4 eliminates 4 here, so this has to be 4, and this is 8, and that eliminates all possibilities for that cell there. So this cannot be 4. This has to be a 1-8 pair, which eliminates 1 and 8 in the rest of the column, so this can't be 1 or 8. This can't be 1 or 8. And this has to be 1, 8, 3, 6 to add up to 20. Well, this can't be 1 or 8 or 6, so this is 3. 3 cannot be any of these. This is 1, 6, or 8 here. We have a 1, 6, 8 triplet in row 4, which eliminates 1, 6, 8 in the rest of the row. So this is 5, which means this can't be 5. Where's the 4 then? This can't be 1, 6, or 8 here. This becomes a 2, 4 pair. That's the only possibility now, and this has to be a 5, 7 pair. That 5, 7 pair eliminates 5 and 7 in the rest of column 6, which eliminates 5 and 7 here. So this is 1. This 2, 4 pair eliminates 4 here, so this is 8, which makes this 1, which makes that 4. This 8 eliminates 8 here, so that's 4 and 8. 1 eliminates 1 here, so that's 6 and 8 here, so that makes that a 1, which makes this an 8 here. The 6 eliminates 6 here, it's 1. This can't be 1 or 8, so this is 6. This can't be 5. This 3 eliminates 3 here, so this is 9. This can't be 3 or 9, so it's 4, which makes that 3. 4 eliminates 4 here, so that's 2 and 4. 1 eliminates 1 here, so it's 7 and 1. 7 eliminates 7 here, it's 5 and 7. 5 eliminates 5 here, it's 8 and 5. This 3 eliminates 3 here, so it's 9. 1 eliminates 1 here, it's 5 and 7. This has to be a 2. This 9 eliminates 9 here, so this is 3. This can't be 2 or 3 or 9, so this is 5, which makes this 3 eliminates that 3, so it's a 9, and therefore this is a 3. And congrats, I hope you enjoyed. Yep, it's pretty nice. Yeah, definitely about challenging level for a killer Sudoku. The sums, yeah, so the thing is, that's one thing you have to take into account with Killer Cage Sudoku, is that a lot of times, particularly with setters who create stuff in Killer Cage Sudoku, they often use the sums to restrict a lot of things, right? So it was basically the restriction to be able to see this restriction, right? And then to be able to see this restriction here, right? So you have to use sums pretty well in Killer Cage Sudoku, particularly in human set Killer Cage Sudoku. That doesn't work as well for automated ones because they just basically see, is there a unique solution, and then spit it out. And sometimes you have to go through a lot of trial and error to do that. Or bifurcation, as other people say in the Sudoku space. It's become a bad word, but I mean, sometimes it's necessary to solve it. If you try to solve a Killer Cage Sudoku that's generated by a machine, you're not going to be able to solve all of them unless you start doing bifurcation. So that's just the long and short of it. Anyways, I hope you enjoyed this solve today, and I'll see you next time on Frank Puzzles. Take care.